Hello, hope you're doing great. This is Maria Panir Rajan, your friendly software engineer. And in this video, we're going to talk about how we can make use of inheritance in Python. When we talk about inheritance in our physical world, when the parent is a owner of a house, the child automatically also is the owner of the house, right? Through inheritance, the child can inherit, right? Whatever the parent has. So this concept of inheritance in object-oriented programming is also based on that principle of inheritance. So in this session, to explain this concept of inheritance, we're going to take the example of smart bulbs. And these days, smart bulbs are becoming popular, right? So you can, connect the smart bulb to your phone through Wi-Fi, and then, using voice commands, you can either turn the bulb on or off, and you can change the color of the bulb, and it has a lot of these features. But these smart bulbs, when you actually think about it, have actually inherited, right, the attributes of an ordinary bulb, right? So when you take a regular bulb which can turn on or off, and then when you add these new features of voice activated commands, and having the ability to change colors and basically be programmable using your smartphone, then this ordinary bulb becomes this smart bulb. So in a sense, this smart bulb actually is a child of an ordinary bulb. So we're going to implement this using code and see how this all plays out. All right, so let's get started. All right, cool. So we already know how we can create a class, right? So let's just create a class called bulb, and let's give this class a constructor in it with the self argument, and let's have a print statement that says this bulb is created. All right, let's also quickly create an instance of this class and see what's going on. So basically we can just say bulb instance is equal to bulb. So that's it. If we just do this alone, and run our code, we know that an instance of our object is going to get created, and you can see that the constructor is also getting called. That's the reason we're seeing this bulb is created string being printed, right? All right, so let's just add a couple of features to this ordinary bulb. We know that an ordinary bulb can turn on, and let's just add the print statement bulb is on, and also let's add the feature to turn it off. Print bulb is off. All right, so now this is a regular bulb, right? So this is just an ordinary bulb, and in our physical world we know that an ordinary bulb can either turn on or turn off. So let's also quickly test this out, and here we can just quickly say bulb dot turn on and bulb dot turn off. All right, so if you just run this Python script, we can see that when we created an instance of the bulb class over here, right, we can see that the constructor is getting called. That's the reason this init method is getting called. So that's the reason this bulb is created statement is printed over here. And then when we call the bulb turn on, we can see that bulb is on. And when we call the turn off method of the bulb instance, we can see that the corresponding print statement, which is bulb is off, is called, and that's the reason we can see here the string bulb is off. All right, cool. So till now we know these are things that we have already covered, and we already know about this, right? We know this is how you create a class, and this is how you create an instance of the class, and this is how you make use of the methods that are inside of the class. So that's fine. All right, cool. So now let's take it a step further. All right, so in addition to this ordinary bulb class, now let's create our smart bulb. All right, so the way we do that is also similar to how we create a bulb class. We just call it class smart bulb, and over here just for illustration purposes, just write pass. Okay, pass means it just passes that line. It doesn't error out anything like that. It just says pass. I'm not writing anything as of now. All right, we'll just say pass, and but we do have this class which is just an empty class. All right, so if now being an empty class, if we create an instance of it, right, if we can just say smart bulb instance equal to smart bulb. So let's just see what what happens if we do this. We can see that nothing should happen actually, okay, yeah, so nothing happens because it's just an empty class, and we are just instantiating an empty class, so nothing happens. Now with this, we know that we have already proved pragmatically that this is just an empty class, and nothing happens when you create an instance of this class. Pakka. And also, like we also know that, if you just do go here and say dot, you can see that, we have a bunch of these dunder methods available, but this instance doesn't have any functionality, right? Like, it doesn't have any functionality to it because it's just an empty class. But now we're going to see the power of inheritance. So just by making this smart bulb class inherit this ordinary bulb class, we are going to get all the features that this bulb has available to us inside this smart bulb class. Because by design, if you think about it, the smart bulb class also requires this feature of being turned on, and like this method of being turned off, right? So the smart bulb, like in effect is also a bulb, right? So it needs to be able to turn on and it needs to be able to turn off. So instead of reinventing the wheel, right, instead of like just copying and pasting the same code, in theory we can actually do that, right? We can actually copy, and if we just paste the the turn on and turn off functionality, the methods over here as well. Yes, like those features, the same features that are there in this class bulb, you're in effect you are getting them in the smart bulb. But there is this principle in Python called try principle, right? It's called the DRY, don't repeat yourself, right? So here we are clearly violating that principle, that DRY principle, right? We are clearly repeating ourselves, and we're just introducing code redundancy. So let's just remove this, like and let's just keep our pass statement here. Now, how do we get these two methods, like how do we get these two features, these two methods that are present in this ordinary bulb class to be available inside of our smart bulb? And the way we do that, yes, you answered it right, is through inheritance. So like the syntax for like inheriting this ordinary bulb class into this like smart bulb class is inside these parentheses, right? We just need to write the name of the class, which is supposed to be the parent class for our current class. So here the smart bulb is our current class, and which is basically the child, and we are declaring that the bulb class, like the class that is over here, is going to be the parent to this smart bulb class. Just because we have done this, right? Now, like when we create an instance of the smart bulb, you can see now, something interesting is going to happen. If I just say smart bulb instance and dot, you can see that in addition to all the dunder methods that were available earlier, we can see that the turn on and turn off methods are also available, right? So that's so cool, right? That's so powerful, because now I can just turn on my smart bulb. But actually, when you think about it, the smart bulb, inside the smart bulb class, we have not defined any method at all, right? It's just directly inheriting all the features that are implemented in the regular bulb class. So that's such a powerful thing. And like it doesn't stop there, it gets better, right? Like, so here, in addition to being able to call the turn on and turn off methods that are available in the parent class, see, we are able to turn on, like the bulb is created, bulb is on, and bulb is off. See, this bulb is on, created, so that's the constructor of the parent class, right? So so here, even though this child class, the smart bulb class, doesn't even, we have not even defined the constructor, we have not even defined that init method. But still, like everything that is present in the parent, is available for the child. And that's the reason, like here when we created an instance, it says bulb is created, and like, which is basically the parent class's print statement. And then like when you turn on and turn off, corresponding print statements are getting printed from the parent class, right? So now, in addition to this, this child class is also a class, right? So now we can, in theory, do more things, right? We can, create more features, add more features, and extend the capability of the parent class. So that's basically what a smart bulb is, right? So like smart bulb is the next generation of bulb, right? Next generation. See all these keywords. So the smart bulb is the next generation of bulb, which is basically having the features of its previous generation, having the features of its parent, which is basically being able to turn on and off. And in addition to it, it also has this voice commands, right? It accepts voice commands. So let's add this next gen features into the smart bulb, because the smart bulb is the child class. So here again in the smart bulb class, which is basically the child class, we can have our child's constructor as well. So let's just add that. So definition init, and which accepts the self argument, and we'll just print smart bulb is created, right? And now this smart bulb, like in addition to the turn on and turn off features which are inherited, it's just going to have one, like additional feature. Okay, you can add even more, but for illustration purpose, we'll just have one additional feature, which is basically accept voice commands. This again is a method, so we'll just print saying accepting voice commands. Cool. So now, like this smart bulb, right, is having its own constructor, it's having its own init method, and also it is having one additional method which is basically accept voice commands, right? So, and as expected here, like in this smart bulb instance, now we'll have this additional feature of smart bulb instance dot, right? See, in addition to turn on and turn off, we also have accept voice commands, so we can just call that method as well. And if we just like run the Python code, we can see that the smart bulb is created, and bulb is on, bulb is off, and it's accepting voice commands. Now the interesting thing, the most important thing to check out here is, right, like here, now it's saying smart bulb is created, right? So because the smart bulb itself has a constructor available, right? So previously when the smart bulb class did not have a constructor, as in like let me just quickly comment this out. And when you comment out the constructor that is present in the smart bulb class is going to make use of the constructor that is present in the parent class if available. So so let me just quickly run this again, and if you see this, here now it's saying bulb is created. That is like it is printing the the print statement that is present in the parent class's init method, right? So when you have an init method in your child class, or rather a method with the same name in the child class, it basically overrides the functionality of the method in the parent class. All right, so that's basically what is happening here. So when you have an init method in your child class itself, and when you run your Python code, you can see that the now it's not calling this parent method's init method, right? It's not saying bulb is created, it's saying smart bulb is created. And then like for when you call the turn on and turn off, it's still there it's using the parent classes methods turn on and turn off. And finally like when you say accept voice commands, like it also uses that, it uses the accept voice commands from this child class. Now another important thing to keep in mind is the parent is inherited by the child. So the child is the one that has features of the parent, right? And it's not the other way around, right? Like let me just also prove that. So here, in addition to this, like let's just let me just comment all these child class methods, and let's just create an instance of the bulb again, right? So let's just create bulb instance equal to bulb. So here like if we check out what features the bulb instance has, you can see it only has turn on and turn off, right? So that's important to keep in mind, right? So this parent class has only the features that are defined in the parent class, right? It doesn't just because there is a child to the parent doesn't get the features of the child, only the child gets the features of the parent, right? Very important, keep in mind. The child, right, inherits from the parent. The parent does not inherit from the child. Only the child inherits from the parent. Okay, so that's very important to keep in mind. All right, so that's what's going on here as well. Like that's the reason we can't say a bulb instance dot accept voice commands. This doesn't work. It will even error out if we try to do this. You can see that it errors out because bulb object has no attribute accept voice commands. So that's something that we need to keep in mind. There's just one quick small thing I would like to share before we end this video. We saw that this init method like is basically overriding the method that is present in the parent class. But what if we want to call the parent class's init method as well? In addition to this init method that is present in the child class, what if we wanted to call the parent class's init method as well. So there is a way to do that. The way we can do that is basically, making use of this keyword called super. All right. So basically, this super statement is used to call the methods that are present in this smart bulb class's parent class. All right. So right now the smart bulbs class's parent is the bulb, right? So it basically, like the super in this instance is basically the bulb class, and then we can just say dot init, right? Basically whichever method we want to call in the parent class, and that's it. Now since we have this super statement over here which calls basically the init method of the parent class, if we now create an instance of this smart bulb, we can see that when we created this instance, right, it basically went to this init statement, which is basically the child class's init statement. And inside the child class's init statement, we are essentially calling the parent class's init statement, right? So that is the reason it from here it goes to this init statement, and over here it prints the bulb is created. So that's what is getting printed over here. All right. And then after like the commands inside the init statement of the parent class are completed, it again comes back to the child class's init method, and here it continues with the statements that are present in the child class's init. All right. So this is a very handy tool to keep in your toolbox, the super statement, which basically helps us to call the methods of your parent class even when you're overriding the parent class's functionality. All right. So yeah, so this was a quick introduction into the world of inheritance in object-oriented programming using Python. I hope this video was useful, and I will see you again in the next video. Cheers!